Welcome to Grade 12 Math, Algebra Review Complete course. Today I'm going to go over operation fundamentals. Now, if you are not watching from a mobile device, there is a mobile app for this. It contains quizzes and as well as other study materials for you to study algebra. So if you're interested, you could check out our link in the video description below. In my opinion, it is very helpful and it would indeed increase your effectiveness in studying for grade 12 math. The app is for both iPhone and Android. So if you have a mobile phone that is either an iPhone or an Android, check it out. It's free. So let's go over the most basic part of operation fundamentals that you find in algebra. And the most used is brackets. So what does brackets do? So brackets are for people who uses math to organize which operations to go first. Some examples of brackets can be found on this slide as the circular brackets, the square brackets, or the squiggly line brackets. Now, look at the example find below. So x minus y squared. With the circular bracket, you would know that you would have to do x minus y first and then you square it. This is a very different approach if brackets are gone, such as just without the brackets, x minus y squared, which in this case it means that you squared the y first before it is being subtracted from x. So now, more complicated example you could see is the 2 open circle bracket x open square bracket y minus 2 squiggly line z open bracket z plus 1 squiggly line close bracket square close bracket and then circular close bracket. So what you do in this case is you have to do look at the brackets that are the smallest and they don't have any other brackets to interrupt first, which is z plus 1. So you do this operation first before you times it by 2, and then after you times that by 2, then you subtract that value from y. Once you get that product of y minus that particular value, then you could times the whole thing by x. So now by the time you got here, you already got rid of the squiggly brackets and the square brackets. So afterwards you just need to times it by 2 and that would be the answer. For negative signs, it is very easy. Just remember that it's the same as multiply all the values by minus 1. So if you look at the order of operations, if you have minus 3 squared and the minus 3 is within the brackets, then you would know that it's minus 1 times 3 and then you square it, which it means that the minus sign is within the brackets, and therefore you know that when you have minus 1 times minus 1, you would have positive 1, because the order of operation is if a positive number times a negative number, then it would become a negative number. However, if a negative number is multiplied by another negative number, then it would become a positive number. So in this case, minus 3 squared would equal to minus 3 times minus 3, and it equals to positive 9. However, if you look at the second example, you would have without the brackets just minus and then 3 squared. So in this case, it is the same as minus 1 times 3 squared, which it equals to minus 1 times 9, which it equals to minus or negative 9. So now let's look at the last example right here. For if you look at example number 3, so right now you would see the minus sign times whatever that's in the brackets, which is x plus y minus z. So if you redistribute that, and if you think that the minus sign is a minus 1, then you would redistribute that as minus 1 times x plus minus 1 times y plus minus 1 times minus z, which if you multiply all of that would equal to minus x minus y plus z. So now let's go to the basics of how do we deal with variables in algebra. So the most basic operations, as you can see, is adding and subtracting. So a note for this is you can only add and subtract the same variables and in the same order of exponent. So if you see here in example 1, 2x minus 3y plus 6x minus 1y minus 2x. Now you can only gather like terms, which in this case is x would go with x and y would equal to y. So in this case, x, we got 2x plus 6x minus 2x, so that would equal to 6x, and minus 3y minus 1y would equal to minus 4y. Now if you look at example 2, you would have 2x squared plus 9x plus 3 minus 3x minus x squared. So in this case, you can only reorganize this in terms of x squared, x, and no x. You cannot combine the values of x squared and x in the same time. So in this case, we can only do 2x squared minus x squared, which makes x squared. 9x minus 3x, which is 6x, and since there's nothing add or minus on 3 is the only one with which there's no x, then we just put 3 in the answer. So the answer is x squared plus 6x plus 3. For adding and subtracting fractions, you actually have to have a common denominator, which is the bottom part of the fraction, in order for an addition or subtraction operation to work without changing anything else. So in this case, if you look at example 1, 4/5 plus 2/5, you could just add 4 and 2 together because you've got a common denominator, which it equals to 6/5. Similarly, as you can see in example number 2, 2x over x plus 1 minus 1 over x plus 1, you would see that there's a common denominator. So there's nothing else that you need to do. You just need to add or subtract all of the numerators, which is the top part, together. So the answer to this would be 2x minus 1 over x plus 1. So what if there is no common denominator? So what if the denominators are different? How can we add or subtract? Well, then in this case, we have nothing else to do but to make those situations into a common denominator. And how can we do that? Well, we could multiply the other denominators into each numerator so we can combine all these together. So let's look at this complex example below. Now, in this example, it is 1 over x plus 1 plus 2 over x plus 2 plus 3 over x plus 3. Now, in this case, you could see that every single denominator is different. So what are we going to do? Well, to make it as a common denominator, we have to multiply all of the other denominators into each numerator. So for 1 over x plus 1, if we want to have with the base x plus 1 times x plus 2 times x plus 3, 1 needs to multiply by x plus 2 and x plus 3. Similarly, for 2 over x plus 2, they have to multiply number 2 by x plus 1 and x plus 3. And lastly, 3 has to be multiplied by x plus 1 and x plus 2. Now, for multiplication, we follow what is called the distributive law. Now, for example, given that in the situation of x times bracket y plus z, so if you want to get rid of the brackets, you need to multiply x with every single component that is added or subtracted within the bracket. So therefore, in this case, y plus z within brackets times x would equal to x times y plus x times z. So let's look at more complex example for the distributive law. So if we look at the first example here, w plus x times y plus z. So if we can use the distributive law, we can rewrite this as w times y plus z plus x times y plus z. So, and if we multiply this further, this would equal to w times y plus w times z plus x times y plus x times z. So now let's look at another example, more real-life example that it would occur to us in the some of the exams that we see in school. Now, in this case, the bottom example, x plus 1 times x minus 2. This could be rewrite as x times x minus 2 plus 1 times x minus 2, which if we redistributed it, we would have x times x, which is x squared, minus 2 times x, which is minus 2x. And if we look at the 1 times x minus 2 side, we would just have plus x minus 2. And if we collect the like terms together, we would have x squared minus x minus 2. Now, let's look at another rule. This is known as the cancellation law. So if we look at the example, x times y divided by the product of x times z would equal to y over z, given that x and z are both not 0. So why is that? Well, if we look into this rule where x to the power of m times x to the power of n equals to x to the power of n plus m, if we rewrite all of those into power of exponents, we would have x to the power of 1 times y to the power of 1 times x to the power of minus 1 times z to the power of minus 1. And if we can recombine those terms, you would have x to the power of 1 minus 1 times y to the power of 1 times z to the power of minus 1, which means that it is x to the power of 0 times y to the power of 1 times z to the power of minus 1. And it's a rule that anything to the power of 0 would equal to 1. So in this case, it would be 1 times y over z, which it equals to the answer, y over z. And lastly, I want to talk about rationalizing denominators. It is very confusing if you put the roots in the bottom of the equations. So you usually want them in the top, or the numerator in this case. So how would you do that? Well, you would know that roots without any number on the check on the little check on the left hand side of the root means that it is to the power of half, right? So what is in this case, what you only need to do is times both the numerator and the denominator by the same denominator to get rid of the root. So let's look at the example. 1 over root 2. It can be rewritten as where 1 over root 2 can be multiplied by root 2 over root 2, which is exactly the same thing because root 2 over root 2 is just 1, right? But we just try to reorganize the whole number. However, if we do that, we can get rid of the root, because root 2 times root 2 equals to 2. So if we multiply 1 over root 2 by root 2 over root 2, we would have root 2 over 2, which is essentially the same number. But now you get rid of the root 2 in the bottom, and instead the bottom denominator is a whole number. So that is the end of this lecture. Thank you for watching. If you are interested in more of our videos, please visit our YouTube channel. The name of the YouTube channel is Mike Tutor, and I have a lot of learning videos that covers the grade 12 subjects. We also have a link in our YouTube video descriptions. That link would lead you to our site, where you would find some quizzes, other study materials pertaining to this course, as well as a link to our free mobile app for your iPhone and Android, where you can view all of the study materials and quizzes from your mobile device. And if you enjoy looking at our videos, and if you want to support us, please like our videos, share it with your friends, share it on Facebook, Twitter, as well as subscribe to our channel. I hope that you find this information helpful. Have a great day.